Howdy. The city of Nolanville is a small but passionate city that is eager to grow into a leading representative of smart city design. We are Synergy Creative and have developed innovative, smart, and sustainable solutions to create a regenerative future for Nolanville. As part of our team, the community is very important to us. That is why we were very active in the Endeavor Tech Initiative Day in order to understand the key issues that are important to the people. You can see photos of our group collaborating on our work and interacting with community members during the Endeavor Tech Initiative Day on this slide. Nolanville faces 5 main challenges: mobility, communication, and connectivity, safety, lacking a smart town campaign, and the environment. Our team addresses communication, connectivity, and environmental concerns through solutions that reimagine future development strategies, smart city goals, and machine learning. Our team provides a bridge between the City Council and the community. Our mission is to develop solutions that create a strong sense of place through a well-structured downtown, clear development strategies, and concise vision for the smart future of Nolanville by honing in on solving environmental and communicative challenges that Nolanville currently faces. In order to make a significant impact towards achieving the goals of Nolanville, our team's scope is broad. Largely achieved through leading smart design initiatives, we offer an innovative machine learning tool. We think the response to environmental challenges bring identity and character to the downtown, all synergized through a plan for a living lab. Some goals include suggested actions or decisions based on patterns in collected data, landscape, sensory input, and growing demographics. Define traffic patterns to provide automated solutions. Understand city structure is also impacted by ecological and environmental conditions. Not only implement smart technologies throughout the city, but create an educational space that elevates Nolanville as a smart city leader, encourages public involvement, and creates economic and research opportunities. Our team has worked collaboratively to assist each other throughout the project. By utilizing their skills in programming, machine learning, and UI/UX design, members from electrical engineering, computer science, and visualization are able to work together in order to develop the map tool prototype. By presenting numerical evidence on green zones, members of urban and regional planning are able to provide a detailed analysis on the benefits of green zone. Through detailed analysis and research, landscape architecture members have created action plans for a connected, community-oriented smart city for the future growth of Nolanville.
So one of the team's main objectives that we were trying to accomplish was creating an interactive map. The interactive map would implement GIS technology and machine learning to function as a map and data tracking tool. The ideas behind it were that it can assist the local government with making effective and efficient design decisions for the city growth in the future, set priorities for future development based on data collected, monitor trends and forecast patterns, create and maintain collaboration at the local, state, and national level of government, serve as a database that can maintain tracking of important and relevant information. Essentially, this is a mood board that showed kind of what we wanted to accomplish with the tool visually. We wanted it to have these really cool, interesting data visualizations that would communicate data to users effectively and in an interesting way. This is another mood board that we created to kind of keep our design direction all on the same track. We moved with a darker theme for the map. That way we could use a lot of high saturation accent colors to highlight the important pieces of information that we wanted to bring out to the user. Onto iterations, we started off kind of pretty basic and primitive, trying to just figure out how we wanted to convey all of the the tools and information that we wanted to highlight.
In its initial brainstorming phase, the color palette reflected Nolanville's town colors. The layout was designed to have ease of access and was initially designed as with a web page format. This was later adapted as a web program instead. This interactive tool expresses crucial data through a cohesive UI/UX design to city officials and stakeholders to provide informed, holistic decisions based on predictive data and trends. This is our team's interactive map prototype. The prototype features several web pages that interact and loads layers of information for the city of Nolanville. There are buttons to toggle transit and traffic overlays onto the map, with space to add additional map overlays in the future. Viewing and filtering data through layers will be a valuable asset for users. This is the main feature of the interactive map page, shown here through our traffic overlay map.
An interdisciplinary project between the computer science students, visualization students, and a few of the other teams, we created a website for a few of the projects we had for Nolanville. Our site is currently hosted on GitHub Pages and can be viewed by the public at this link. Unfortunately, it requires a user to sign into GitHub in order to view it. The site opens on a landing page as seen here with our team logo. There is a header to navigate between the pages and a footer with all the members of our team on every page. The next page is an interactive map, as discussed previously, with a proof of concept for what the visualization students had in mind with their project. Here's a version of the interactive map page showcasing the buttons to put overlays and filters on the map. Currently, we have implemented buttons to toggle traffic and transit map overlays, but there is space to add many more features to this interactive map that the visualization students discussed previously. The results of these overlays can be seen here. Next, we have a page with some information from the machine learning research that Dylan and myself did, which we will go into more detail in a few slides. This page features some visuals from our research, such as the number of data features effect on the model accuracy and other hyperparameter tuning. Is an overall summary of the machine learning research. Finally, we have a page for the future city development. Currently on display on this page are some of the future phase site plans spearheaded by Lauren and the landscape architecture team that they will discuss further later in the presentation.
So, as a lot of people know, a major issue in Nolanville involves the cause of heavy traffic due to the train that runs through the middle of the city. A solution to this problem would be to provide residents of Nolanville with a publicly available train schedule that denotes when the train will pass. Such a schedule currently does not exist, so we have made it our goal to develop models using machine learning to help predict when this train will most likely pass. Our process to develop these models began by collecting and evaluating train data from another city that was publicly available. This is what you see on the slide. The idea is to use the exact same techniques we would have used for Nolanville train data on another city's train to demonstrate the proof of concept. The table of data here shows different input features or characteristics that describe the time the train passed, and then an output feature in the last column that predicts whether or not another train will come in the next X minutes. In this case, we use 15. With this data, we ran several different machine learning algorithms that attempted different ways at predicting whether a train would come or not. Such algorithms or models we used include feed-forward neural network, k-nearest neighbors, forward feature selection, AdaBoost classification, and ensemble learning. Our highest performing model on average was the ensemble learning one, producing a consistent 85% to 95% accuracy rate. Collecting information from each of these models, such as graphs or visualizations, how important each feature is, and how accurate the model performed, provides us lots of value and can be easily applied to Nolanville. Future implementation of our models would require train data from Nolanville, specifically the times at which a train crosses a certain point in the city. We hope to accomplish this by using sensors to signify when a train is passing. If this data can be obtained, our models would serve as a tool to residents of Nolanville by allowing them to insert any time of day they would like and receive a result stating whether a train would come in the next X amount of minutes. Successful implementation of our work should satisfy our hopes at easing traffic issues and boost the overall connectivity of the city.
As part of the machine learning interface, we have 2 development proposals that we'll be including in the interface. This will allow the development goals of the city and the status of undergoing and future projects to be accessible to officials who can see the timeline and progress of various projects. The concept behind these plans for the city is rooted in 3 building blocks that are crucial elements in solving the environmental, connective, and communication challenges we are addressing. They are earth, water, and matter. These elements are the basis of our development strategies and produce 2 main goals: creating an anchor for Nolanville's Smart Town campaign and preparing a future plan for citywide development. Our first development strategy that achieves our goal to anchor the city's Smart Town campaign is a living lab. The site for this is a 107-acre plot of land located in the south portion of Nolanville, right off of the feeder of Highway 190. The living lab, located in the rightmost portion of the lot, will only utilize about 55 of the acres. It is currently privately owned, but there has been coordination with the city about future development.
Our goals for the Living Lab are to provide a research incubator for new sustainable and smart design methods, to bring economic opportunities through emerging technology, to support the local economy, to offer a space for all residents of the community to visit and get involved, to showcase cutting-edge smart solutions that engage the small town, and finally, to create educational opportunities for the residents of Nolanville and all who visit the Living Lab.
This slide is where we have our site plan of our proposed Living Lab idea, which, as Lauren said, it is located at the bottom right of Nolanville. This slide goes into detail where the general location of all places we are proposing for the Living Lab.
Our second development strategy is a plan for the future build-out throughout the city and is supported by our team concepts of earth, water, and matter. First, to increase green space throughout the city, we developed a greenbelt plan that connects a series of walking and biking trail systems that align with Nolan Creek for a majority of the trails. It helps accomplish connectivity between the north and south portions of Nolanville, which are currently fragmented by Highway 190. It helps restore suffering ecologies. It dedicates acreage to publicly accessible green space for future development of Nolanville.
When analyzing a case study in Harlem Place, Los Angeles, we can better understand the importance and benefits of green zones. The graph to the far right is representing several species of trees that were planted in a green zone located in Harlem Place, Los Angeles. Each species had 9 trees of its type planted in a green zone. Over the course of 1 year, the trees had successfully removed 1 to almost 9 pounds in common air pollutants. Not only do green zones reduce air pollution, they also provide adequate shading. They act as natural noise buffers from vehicles, and they encourage wildlife diversity. Utilizing the same case study in Harlem Place, Los Angeles green zones, we can also quantify another important role of green zones, such as the amount of carbon sequestered when communities take advantage of green zones. Still looking at 45 trees, according to current findings, a shaded tree can sequester 4.5 to 11 kilograms of carbon per year. By just taking 45 trees as our example, we can multiply that number by the lowest possible estimate of 4.5 kilograms of sequestered carbon per year and get 202.5 kilograms, or 445.5 pounds for our scale. A medium estimate of 767.25 pounds and a maximum potential of 1,089 pounds of sequestered carbon. Clearly, green zones can help communities reduce their carbon footprint as they provide critical ecosystem services.
With the element of water, we would like to create a space in Nolanville that would achieve these 3 main goals. First, we want to enact an active stormwater management system that would help Nolanville control the stormwater in the city and recycle it effectively in the future. Second, we want to create a blueway that makes Nolan Creek accessible to the public and promotes recreational activities. And third, we want to use water as a tool to grow food. All of these goals could be accomplished with the implementation of the Living Lab, as well as with our long-term phasing plan for the city of Nolanville. This rendering shows an example of how the hydroponic garden within the Living Lab could function. A portion of the plants grown in this area are grown without soil. Instead, the plants are grown using a water-based, nutrient-rich solution. Since there is no soil directly around the root system is supported using an inert medium such as perlite, rock wool, clay pellets, or peat moss. The basic premise behind hydroponics is to allow the plant's roots to come in direct contact with the nutrient solution while also having access to oxygen, which is essential for proper growth. The result is a plant with a smaller root system and a greater flowering potential, with an increased yield and a more nutritious crop. The beauty of a hydroponic system is they can be utilized in any weather condition and be done virtually anywhere, whether it be indoors, outdoors, or in a greenhouse. Some systems have been designed to use up to 10 times less water than traditional growing methods. Due to soil not being used, plants can be placed closer together, which reduces the space needed to grow the same amount of food. Hydroponic systems also decrease the time between harvest and conception, which increases the nutritional value. And as if all that weren't enough, no chemical weed or pest products are used in a hydroponic system. As a part of our living lab, there will also be a research center. Within this space, there will be greenhouses as well as various other incubators where many different kinds of smart technology can be explored, specifically smart gardening. In the greenhouses, researchers could experiment with high-yield plant growing technologies such as phenotyping, plant breeding, and high-yield crop production.
Currently, the downtown of Nolanville is lacking in identity. With the current situation of the unused land and the condition and layout of the streets, it is difficult to truly know where it is. A few implementations we are proposing are the redesign of a streetscape to a more walkable and pedestrian-friendly with the help of smart technology, but also keeping the small town feel that Nolanville already has. Currently, the streets are a single two-way streets with no median and or little to no sidewalk. With this new redesign, the sidewalks will be added on both sides of the streets, which will have adequate space for pedestrians to walk comfortably and not too close to the actual street itself.
There are many potential benefits that Nolanville can see from rejuvenating their downtown and streetscape. We did a case study on another town in a similar situation as Nolanville called Statesville in North Carolina. They were losing businesses in the downtown area and were struggling to attract people to shop at the businesses that were already there. So they did a full overhaul of their downtown streetscape, installing wider sidewalks, a tree buffer, slower speed limits, and an overall more appealing aesthetic. The outcome of this project was overwhelmingly great. It drastically improved the quality of life and safety of the downtown area. This allowed for community members to walk the downtown area, not only improving the health of the community, but also bringing more foot traffic to the downtown area that was much needed.
All the projects and plans we propose have been developed with the community in mind, and I think that's the key point that we want to end this presentation on. While working on the projects, the one thing that everybody always has had in the back of their head was that somehow that we can really, these plans and ideas that we're putting forth, they can really impact the community in a positive way. And every decision we made, everything that happened, that was the goal at the end of the day. Hopefully these plans and ideas can in some way help the city out, and if it has, then it's all been worth it.